Hello everyone and welcome to today's live stream where I am trying to figure out a math problem, and I thought, you know what, I'll be good to live stream my pain and suffering. Well, it hasn't been that bad, but it may be educational. I'm trying out the separating axis theorem to figure out if two cubes are colliding. Now you may be wondering, wait, why don't you use your SDF method that you tried before? And while that can work, it would maybe be less efficient than what I'm doing here. Basically, collisions between the corner and a face of an object has been very annoying, and I want to figure out how to do that properly, going through the fundamentals. Though, then again, just doing... Yeah, I'm trying to figure out this kind of stuff. But yes, so the separating axis theorem... I watched a very nice video by Seth Bling, a very, very old Minecraft YouTuber, who was trying to implement rigid body physics into Minecraft, where the separating axis theorem was very much needed. And to do that, you basically, here, let me just explain what it is real quick. You take the axes of one cube and the axes of another cube, and try to determine if there is a separating axis between them, by taking axis 1, 2, 3 here, 1, 2, 3 here, and then cross-producting each pair in between there to figure it out. So 15 axes in total. I've done a little bit of work and set up something to compare the axes automatically, which, let me just explain. Maybe this will be helpful to someone, I'm actually not sure. But what this does is it takes in cube 1 and cube 2 and gets the face normal, as we can see here. And the index here will go from 0 to 15, so we have 15 entries, including 0. That's why it says 14 down there, because indices start at 0. They do not start at 1. So here we can see the pattern is 0, 1, 2 for the 3 axes, -1 just to mark it as we're not doing that at the moment, and then axes 0, 1, and then 2 for the cross product part there. And then for cube 2, we do -1 because it's not being used yet, 0, 1, 2 for the main axes, and then 0, 1, 2, 0, 1, 2, 0, 1, 2, so that it'll compare each axis of the first cube with the second cube. So that's the pattern, totally not confusing whatsoever. And then what this part does is it switches between cube 1, and then this one switches between cube 2 axes to the cross product mode, as we can see here. So cube 1 axes, cube 2 axes, and then the cross product of all the pairs. So that's the idea. And then normalize it because for some reason the normal, wait, all these should be wait, I need to check a few things. Go and check some of the data with all of this. We go and get the spreadsheet out again. Because oh, actually, wait, I don't need the spreadsheet because this supports singular values. Okay. So that's a problem. That right there should be outputting here. Let's see, that one, yep, that's correct, 0, 1, 2. And that one, for some reason, that is normalized, isn't it? So why when it goes to, that one is not normalized and then I have to normalize it? That might be a mistake that I'll need to figure out later. But anyway, just to showcase the axes in action, if I flatten the cubes according to the axis, we can see if they have a separator. Now, the part that I don't understand is right here. It looks like they're colliding, which kind of makes sense because I'm projecting them from the top. But the thing is, should I be projecting them from the middle here? No, it should be like that, if I understand it correctly. If anyone else knows, please let me know. Here we can see that there is a axis for that. That one, they don't appear to be colliding. This one, maybe. If all of them appear like they are colliding, maybe that's what needs to be done. So I'm going to set it up so that I can see every iteration of this. So yeah, how should I do that correctly? I should put this into a node group, but for now I'm just going to put it into a frame. So here we have cube 1 and cube 2. And then, yeah, I just need to join the geometry into here. transform the previous one by 1 on the z-axis, just so that we can see what is going on. So if I plug in this, we should see every single cube. Okay, we need to move those over a bit more. Every single projection axis of the cube, in theory. So it should be iteration 0, 1, 2, 3, 4, maybe 14. Yeah, that seems to be correct. Oh no, it should be 15, right? 0, 1, unless it starts at iteration 1 instead of iteration 0, which I'm pretty sure it starts at iteration 0. And then I also need to do the collision detection check. So the question is, how do I do that? I think what I need to do is make it so that the... I would need to take the median point between the two positions and then see if cube 1 is after the median or before. Basically seeing if they both overlap. So if we take a look at these, I'm still not sure about you. This is the last axis. Let me just, yeah. So again, 1, 2, 3. 1, 2, 3. Yep, all those seem to be good. We can see that some of them are not colliding. And then we can also see how far inside the other cube they're colliding. So maybe I have a good basis for this already. But this is going to stress my poor little brain out. Just a little. It's a good thing to do today, because I have some time to kill. But yeah, we can see that one, they're not colliding. Yeah, how do I figure this out? I should have more papers up on the side to figure this part out. Separating axis theorem. This will not be a standard stream today. I'm just going to be trying to figure out, I will be trying to figure out some stuff. Let's see. But I hope you all had a wonderful Thanksgiving. I had a fun one. Let's see. What to do. Just checking all the boxes and all of that. Okay. So the visualizer is helping, but maybe I should make it so that I have like a line. So let's do a curved line as a visualizer to see, yes, let's start in the direction. Let's make this like 100 meters. So here we can see, yes, oh, that's quite good. We can see each axis that everything is being projected onto. You can see, yep, that one's going, let's make this 1 meter instead. Or 2 meters? That might be a bit better. Okay. So, up, that, there, there. And then this is where, let's see. This is where it gets fun, where it's doing all the cross products. Yep. So what I need to do... Wait, no, that's going to be the funky part. Because I need to tell how far away these parts are. Wait, does that work? I'm gonna play Seth Bling's video again just to see... It's flattening them along the axis, so I'm doing something wrong. Oh, wait, I need to use a vector project. Or is it a vector rejection? I keep forgetting which one. If we do a vector project, we do that. Scale by -1 to make it a vector rejection. That does not appear to work at all. Maybe. Dang, I'm forgetting how to do this. I need to take the inverse of the dot product. No, but that wouldn't work either. Like cross product this axis and then do basically the same thing there, because these need to go along this axis, not against. I'm pretty sure. Please make evolutionary algorithm for optimization in geonodes. I'm assuming you're meaning like a neural network type of thing. Which, that will probably be possible in the future when lists get in, well, I guess currently it is possible, but it would be a huge pain in the butt. So I'm kind of waiting for lists to be implemented before I take a whack at that again. Though I have made something like that in the past. The separating axis theorem. That's why this doesn't look right. It's because I have it set up wrong. So basically, I need to take all these and... yeah. Do the vector rejection. You set that to be -1, and then subtract this potentially from you. So maybe that'll work? Potentially? Invert? Maybe that did work. Oh wait, I think that worked. Okay. Intriguing. Oh wait. I just, no. This needs to be the position, right? Nope. It has to be that. I'm getting there eventually. Or maybe. Subtract, and then what if I just take that out? No, that does not work. But that does work. Okay. Not the worst. We're getting there. Eventually. Through trial and error. Lots of error here. See, let's bring this over to there just to keep everything nice and organized. So even though it's much harder to see now, we are projecting these onto the axis. And we're still getting the issue that looks like more of them are colliding. Or, no, that's planned. That's not an issue. That is completely and totally planned. Let's save this in its current state. So again, we do that, project them onto there. And then we need to see. We basically need to do a dot product between... No, we already have the dot product there. We need to do an attribute statistic. Let's see. Between these, to get the mean, I'm assuming, and then seeing if any one of them cross over that median. Or we need to check if cube 1 is over that median and if cube 2 is over that median. Basically, if they overlap at all. Which will be fun. Take the min and max and the min and max. Basically converting it into a one-dimensional bounding box and then checking that part? The mean of that, take the mean of that, and the size, and then that, no. This hurts my brain. I'm trying to think about it in a visual way, but it's just not visualizing correctly. We do have the mean, because we did join the geometry parts here, which probably, maybe I shouldn't have done. Here, it's just a matter of dot producting that. Okay, let me copy this. Hide the old one and see what I can do from here. So, yes, boring stream today. Lots of math going through. But the idea is that we do this for every cube individually instead of both of them. So I think I'm going to need to turn this into a node group to make the comparison work. Hello to everyone in the chat. So again, if we get these statistics so that we can get a single value from this, we can get the min and the max and the median, but that will give us like the one-dimensional bound. So this will give us, according to the dot product, like 1, -1, I assume. And then we need to check if cube 2 is within that range. If either the min and the max of the other cube is between there. There has to be an easier way of doing this. Alright, another node group. Node, make group. And the thing is, I really wish we had a node for this inside of Blender already, or just a general collision points node. But we are not in that future. Again, we have this. I am going to... Man, my voice is really dropping today. I am feeling a little bit ill, but that is kind of the norm for post-holiday stuff. So again, we have the cubes. We can get there, the min and max data from there, along the axis, and then we just need to compare both of these. Because I still don't want to... Should get the range. The range and the sum might be the easiest way of doing that. Or no. Well, I could... if I get the mean of the two, and then check if any of the vertices cross over that mean, that would be the way to do it. But that means this would need another level of this, which we're making this more expensive by the minute. So if I get the mean between these, or the average, this would give us like right here, this would give us right there. And then if I average those two, it would give us the midpoint. Find the point of separation. And then all I would need to do is test cube 1 or cube 2 are over that line. And then if that happens, we know that there's a collision pair. So again, right here, we have cube 1, cube 2. This will just be axis data or something like this. So we have both of those. And then we need to add both of them together and then divide by 2. So add, divide by 2 to get the average. Which I could just join the cubes, do this, and then do that, which may be better, and then compare them to the cubes afterward. Yeah, that's probably the way to do it. Or... I still need to mark them as cube 1 and cube 2, so I still need to do the test afterwards. No, that kind of, I'll still need to do this, but I would need to do it a third time. Would make it more expensive. Oh, this sucks. No, we don't need to do that just yet. Okay. We have that and that. And then we'll need to do this again to see where everything lies. Not the happiest about this. Here, let's go and capture. Because technically we don't actually need the dot product to offset the position. I'm doing that purely for on a visual side. So if we take that, then get the mean, which, let me just make sure all that's connected, and we pass this through out to there. And then for each cube, I should just join the cubes. Alright, no. Gonna do this in a different way. Alright, that's the process here. So right here, we're going to join the cubes again. So take that out, take that out, take that out, put that over there. You over here. Come on, buddy, work with me. So right here, okay. And after all that annoying stuff, I'm going to store which one is cube 2. Oh, you're cube 2. Okay. You're cube 2. And what the heck will put you there? So this will be the ID for cube ID, because, well, it doesn't need to be an integer. This will default to 1 when these get joined, so that'll be fine. So I will be able to separate these, compare their data, and just, okay. We need to get this to work first, and then that. How much more expensive to converting to volumes? Converting to volumes would be horrendously expensive compared to a good separating axis theorem. In theory. Because, well, volumes, when you convert a mesh to a volume, you are using the separating axis theorem, kind of. I'm doing this between two cubes. Because that's like the basis for all kinds of physics. Or no, that physics engines usually use axis-aligned bounding boxes, which is kind of similar, but I'm making this difficult on myself on purpose. Okay, what was I doing here? This will just be axis distance or something. Axis distance. So that'll replace you, so we won't need that. We're just gonna go here, take you, put this over to here, put this over to there, and that should be good. So now we just need to compare. We don't need you anymore. Hopefully making this as simple as possible. And then we just need to tell if any vertice crosses over to the other side. How do we know which side is the other side? That's the problem here. How do we tell? Oh, this should be easy, but my brain just is not functioning. Could you make more geometry node effects for videos? Unfortunately, no. I am rather burnt out on GeoNode stuff. Probably because I keep doing stuff like this. But for the effects, I'm basically just doing tons of work. So I do not have time in my very busy schedule for more YouTube content. This would not be live streamed if I didn't think someone could either help me or get helped by this. Live streams are the only thing I can justify spending my time on now. Let's see, axis distance, just because I have a quite busy schedule. Axis distance, and then we get that, I can feel the gears in my brain just grinding to a halt. The thing is, how do we tell which side of the mean? Because I could just say, hey, is the axis distance greater than the median or mean? But for that, I would need to separate both the cubes to tell on which side the thing lies. Dang it. Or... So I need to tell on which side the cube... Okay. So confusing. Okay, so if we take the axis distance and then we use a greater than and compare that to the mean, we will see that if we look over here, we should see that that is working, right? Here, let's go and get the attribute text out here. We get true, true, and false. I'm assuming the middle part is right there, which we could... If I go and get a curved line again, and then set a direction, we can use the mean for the length, and then the axis. The axis for the direction, and this should point directly towards the midpoint, just to see if that'll work. Okay, yep, the midpoint is right there. So this is working. Just barely, which that is very, very funny. So we have false here, and then everything beyond there is true, because that little line right there is the midpoint, so it's just barely above. So that one's there and that one's there. So that one marks it as a collision pair. But wait, no, I have this all wrong, don't I? Perpendicular. And those get flattened to the plane of existence. Something isn't right. Sorry, I'm looking at the video again as a reference. Yeah, no, something... Is this for collision detection? Yes. Yes, it is. The thing is, I guess I could skip over all of this if Because if I wanted to do collision detection between these cubes, I would just have to do the SDF setup I have on this cube, and then on this cube as well, and then see if there's any parts that collide between the two. So I would have to do... Maybe that would be faster? Just using what Blender already has. Because here... Yeah, no. Find corner to face collisions, that would work, even if this were bigger. Okay, let me just try a slightly different method. We have our main cube, and then you right there. Yeah, good. They're not connected. Okay, so I just need to bring in... That is cube of 4. Okay, that won't confuse me at all. So let's do SDF. Mesh, which is a node group I have. This... oh, wait. This is the fancy one. Okay, so we just need this on the faces version. Don't worry about everything else. So this one will run on here and then say, are any of these relative? Relative, there we go. This will let us know which parts are inside or outside of that cube. So this solves collision for there. This part is colliding. And if we run on the other cube as well, so we basically have 2 of these set up, this will give us collisions. And then we just need to do an attribute statistic. See if any of them happen. So that would be the better method, but I want to do like the raw math method. So it's like, okay. Find the minimum, if the minimum is less than 0, then we have a collision occurring. Right here, this would be the way to actually do it. I guess this is what I'm trying to... Because in here, the geometry proximity node, or the, you know, the other ones I have set up here. Oh, no, that's on purpose. We need that SDF. That does work, and then we just need to find the minimum. And if it's less than 0, in this, you okay, buddy? Where's the cube? Oh, the viewer. So in this case, I don't know, switch an icosphere to be visible if either of these are true. So, if any of these are true, then it'll switch it to on. So in this case, if there is a collision... Wait a minute. This is very annoying to figure out. And the thing is, it gets so much more expensive every time you try to figure other things out. This is only for 2 pairs of objects. It's not even for super complex stuff. Actually, yeah, maybe I should just use the SDF method, because it is probably just better. I just need to... The part that was confusing me... You know, I just need to do it on both meshes, and then get a constant between them, and then... Can I actually get the... Can I actually get the collision point? To resolve the collision through there. Because if I can do that, maybe I can implement that into the rigid biphysics setup that I made ages ago. To try to make at least one pair of collisions actually work. Maybe that would work. And then I just need to find the minimum of all that. Okay. Let's give this a shot. So, in this case, any of those collide, I'll set the scale to be 1. And then I also need to find out the actual collision point. So how do we do that? This detects if there is a collision. How do we tell the actual point of collision? Greater than... No, if any of these are less than that, then it should function, right? Here, let me just check this. Yeah, that one shouldn't do anything. This one should, but why is it switching it to off when a collision occurs? You into there. Yeah, no, that should... Be doing the exact opposite. The min. Wait, what? What's the min right now? Wait, which one do... This is getting extremely confusing and I hate it. Wait, what? Okay. Let's do... What is going on with you? That one's getting the distance, so... Oh, I am a moron. These have to be... Yep, nope, I get it now. The problem was, these need to be crossing because I forgot how the flow of data actually works. So it needs to be like this. Oh, this is getting so horrible by the second. I'm having such a fun time. Okay, now this should work flawlessly. I just forgot that, hey, this one needs to compare with this one and that one vice versa. They need a crisscross. So now, there we go. It was very glitched out before. So again, collisions are working as intended. Actually, if I just made this a cube, it would probably show it a bit better. Though it has to have a size of 2. There we go. There we go. If it does that, that's fine. And then... how do I make it so that I can test the alternative? Yeah, but no, that's testing it. So it tests, yep, that or that. So, that part works. And then, so this is successful collision between those two. And now I just need to see which one will give me the correct normal as well. How do I do that? I would have to find the minimum between... the minimum distance between these two so that the collision can be resolved. Which I already have the minimum from there and there. And then I would also need to find out which one has the correct normal. And then I would be able to resolve the collision. I hate collision detection. It is the most annoying thing in geometry nodes. And the thing that's keeping physics at bay. Collision detection. I'm on the right route, I just haven't done it in a while. So if it's less than 0, then that means the position is good. So I need the normal and the offset. The offset that I need? No, I just need the normal and the signed distance. Whichever one is like that. I need to convert these into singular values, which is very annoying. If I... What is the difference between your SDF node group and the 5.0 built-in one? I made this before the SDF nodes were implemented. This will give... Those ones deal with volumes, this one deals with meshes. So this one will just give you a distance between the surface of... Yeah, how do I explain it the best? Let me try to make this work. Okay. So with normal geometry proximity, it could give you the distance, but it wouldn't be signed, where you can have negative. This gives you negative distance. That's why it's a signed distance field. So there, if it's inside, negative, outside, positive. What if I took the minimum, and then I said, whichever one is that, I get the index from that. Instead of... If I get the minimum, then I say if you're equal, if your signed distance is equal to the minimum, then I get the normal, and then I get an attribute statistic and sum that to extract the normal. That is so dumb. It might just work. I scale the normal by that and then do an attribute statistic. This is absolutely atrocious. But it might just work. So in theory, if I get the sum, this will give me one value. It'll give me one value, yeah, between the two. Or the problem that I'm dealing with now is how do I extract the value per vertex to make it a singular value so that I can send it out to other things. That is annoying and difficult. But if I put this into here, this should place our cube of interest. Or no, that will not give us the actual position of the collision. It's almost as if... Okay. Clean the slate. I need to store all of this data. No, but that wouldn't work either. This is so annoying. How do I do it correctly? Or how do I pack all the data correctly? Because we can get the distance and then find the minimum. We already have that as a singular value. We can use a greater than or less than to determine which one has a deeper collision. And then with that, I would be able to switch between the data between that and that. No, it would be so much simpler if I just stored the data as named attributes and then did all of the comparisons later after I joined everything. Let's see. Named attributes, my beloved. They are the best. Though, if I store them and then combine them, it should be fine, right? I forget if there's some funky stuff with that. So, I hate it. Assign distance. Then I just need to store the normal. If I were to use a capture, I'm getting frustrated at this. When my goal was to try doing this, the separating axis theorem, but I'm running into this same exact BS. I know, but how would I actually figure out which ones are colliding? Because when I project them... all of these are colliding except for one. Meanwhile, the part... I thought streaming this would help because I would do like the... what's it called? The rubber duck method. Where me explaining it would make it easier for me to understand. But it does not appear to be helping, unfortunately. What am I doing wrong? Because again, right here, the separating axis theorem. If I set this to be 0 so that there's no offset, we can see that these two are here. And then we are accurately projecting these onto the axis. So right here, we can see projecting them onto there. And that means that that pair would detect a collision. But is it that... in this case, it would be detecting if any of them do not collide. Like, if one... yeah, no. So if I get the collision detection to work... okay. thank you for bearing with me, everyone. Feel free to leave the stream if this is way above your level or frustrating you, because it is frustrating me quite a bit. Can you summarize what you're trying to achieve? At least for now, I want to try doing the separating axis theorem to find out if two cubes are colliding. Because right here, like, it should just be like this. And this is supposed to be the efficient method, because it only has to do 3 axes of the cube instead of 6. Or maybe, what if I were to... Oh, wait a minute. What if I took the mean? No, but I wouldn't know which one's on top or which one's on the bottom. That's the frustrating part. If I offset these by the mean, I need to get the mean for each cube, see which one's on top and which one's on the bottom, and then see which vertices cross over to the other plane of existence. This is extremely, extremely frustrating for me to try to figure out. Again. If I were to just subtract from here, because we convert that into singular values are... I hate it. I hate it with all my soul. So here, we can see that all of these are now centered. Which means we would be able to tell which parts actually cross over to the other side and cause a collision. In theory. So we can see that quite a few of these are colliding heavily. Or no. The goal is we find ones that aren't colliding, like this one. And that would tell us, and let's get a... Where's that curve? We don't need that curve anymore. This would tell us whichever ones are not there. So, in this case, ... If any of them are not crossing over that path, that would work. But we need to figure out which one is on which side. So, let's get this back up and running. So this works. And then I just need to switch the selection. So here, if I get the ID, it's that one. We can get the mean of u. We won't even need that one, I don't think. And then if we set this to be not, that would give us the inverse. So we have the middle point of these two. And then we just need to use a greater than to see which one is on top. And then we need to use another greater than or less than, depending on which. So we'll use a switch node. And then we'll do that or that. That'll be a Boolean switch. So less than or greater than. So in theory, then we just need to do this part. So with all this super complicated math out of the way, this should ... tell us if there is a collision pair. Or if there are parts that are overlapping. And then we need to check if any of them are not. So we need another attribute statistic to give us a final result. Which in this case, I will reveal as the scale of an icosphere in my classic fashion. So, if the sum is... Well, this just needs to be... I'll do less than 1 instead. What the... What? Oh, wait. I meant to put that into there. Okay. So in this case, we should see, in theory, I might need to swap this part around. Then, please. The love of all that is holy. We do not need you. We do need you. So that's a greater than or a less than, depending on which that part is working as intended. That one is the mean. That works. Okay, that's good. This one will be that, which works. This one will tell us which one is above or not. So the attribute is that one. Okay. So again, in theory, everything should be working as intended unless I screwed something up, which the chances of that happening are quite high. If any of them are not colliding like this one, we should see an icosphere pop up, but we're not seeing that at all. Let me just check this. Yep, we should see an icosphere. So, what is the problem? We're checking if either of those go through. Checking which one is above or below. Let's see. And we stored this data, so even after we move it, that will not be a problem. So what's the issue at hand? Looks like we need to debug once again. Again, right there. We're checking. Yeah, no, that should work. So, with that. Oh, shoot. Wait a minute. Or no. I'm getting frustrated again. Do I do the subtraction beforehand? And just check if any of them cross over. Or I could make it so that neither of them care about that. Oh, wait, that might be a good idea. Wait. If I go and subtract this from there, this should put these in the midpoint. And then I go and multiply one of them, so that's a negative. But I still would not know which one's above or below. That sucks. Or maybe I could just make sure they're not on the same side. Nope, wouldn't work. I thought this part would. Again, let me go. Oh, that one's set to, they're set to median. Whoops. That could possibly be a reason for failure. Yeah, and then we can put that there. Do any of them? Nope, all of them are reading as none. Let's go and put you into here. All of them are reading. That is not good at all. And we're already 48 minutes in and barely any progress has been made. Maybe I'll just need to come back to it another day. This is one of those projects where I either get it in the first hour or I don't get it for the next 5. Nothing in between. Let's see. No, I don't need to go just yet. So again, oh, come on, I didn't mean to hit that hotkey. Control H. And we have that. Again, the mean of one, and then we get the mean of the other, and then we get the mean of that one. And then we do the comparison between if it's less than or greater than. But it should probably be This switch should probably be the CID versus the other one. Because that would tell us which one is doing something. If we mute that, we can see all of these are reading as only one. No. Wait, what? That's interesting. Oh no, it's reading as 0.5. If we do this, we can see that that's happening. Yep. Let me go and check just this in general. So again, that one's reading as true, 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 then false. There should be ones that are all reading as false. Wait a minute. This just inverted. Greater than. Maybe that works. No, it does not. Who knew this would be so annoyingly difficult? Let's go and chop out you. Okay, so which ones of these are not colliding? Yes, this is the golden boy. This one will determine whether or not I can figure it out. Oh, wait a minute. I am a little bit dumb. This is so easy to do. Wait a minute. Wait a minute. I figured it out. Okay. Wait, no, wait. Oh, this is so... I just need to tell if the min and the... No, I'm doing loops here. I just need to see if the min of one is greater than the max of another. Yeah, wait. Should just be this, right? The min is greater than the max, and then maybe vice versa as well. So if either of those are true... Yeah, no, that was it, right? Bingo! Who knew? Wait. Yep, no, I think that works. I was just being dumb the entire time. Okay, good. It did not need all of that stuff. And I'm pretty sure that this is still working. Because, yeah, if the minimum is greater than the max of the other, that means they're colliding. Yes. Just, hide that, collapse it, so that is our final collision detection. Planning it onto one axis and then doing a bounding box detection, essentially. So, let's set that to be 0. And then checking here, yep, this just determines which ones are colliding and which ones are not. So this means if any one of these are true, that means there's no collision. So I think this is working now. Maybe it is. Maybe it is. And I do have a singular value to determine that. So now, this will be not colliding. Oh, wait, caps lock on? Not colliding. So, in the repeat zone, I could just do this, make this an OR, so that they can stack up. Then with all of this, this will output a singular value to say, hey, are these two cubes colliding? So, with all that, I'll just have a single icosphere. Actually, wait, no, let's make this a little bit better. 2 materials. One will... Oh, and I haven't saved in ages. Okay. And there are more efficient ways of doing this, I know. But for now, I just want the minimum viable product. Which, okay. So if any of those are true, I'll switch between that material. We got there eventually. How is it so difficult for me? Okay, got there eventually. Okay, so actually this should be inverted because I want the collision to be red. Okay, so now, yay! I could determine if two cubes are actually colliding. Oh wait, and the previous one wouldn't work because edge-to-edge collisions. Holy crap, it actually works! Huh. Oh, wait. Yeah, no, it does work. Okay. I don't think this one would have worked because edge-to-edge collisions. I don't think it could support that. So if these did that, it wouldn't have worked. Yeah, no, that was the problem. Okay, that one would not have worked. Yay! It works! Dang. So, okay, now that that one works, let's go and duplicate it, hide it. Huh. Okay, now let's try to optimize it a little bit. So, what we need is to not do any of that. And then potentially make it field compatible, which, that's a whole nother story. Let me duplicate you and you. So, we do not need you. Or you, or you, or you. We just need a dot product. And that's like that. Okay. It works. Yes. Then the min and max from here. Since, yeah, no, I can just do this per cube instead of the other one, and then that, and then that. Yeah, no. We don't need you. We don't need you. We just need you. We don't need you. We don't need you. And then we don't need you, and we just need two inputs. See, now that I figured it out, I can optimize, and hopefully it still works after what I do here. So, I just need cube 1, and this one, another input. Everything just clicked in my brain. There we go. So I need this. I no longer need you or you. Yay. I think I understand this now. Potentially. Then here, we don't need you. We just need you, and then that. Don't need you anymore. These can remain as is. Ugh, that is nice. Okay. Let me just run it 15 times, going through all the axes. How long does this take? It's gonna take over a millisecond. Well, it's still under a millisecond, but for axis-aligned bounding box collisions. Actually, and one issue. Oh, wait a minute. Does this work if these are different scales? Okay, we got that, we got that, we got that, we got that. Okay. Oh, this will only turn one of these red or green or whatever. There we go. Mm-hmm. And then right there. So, I think that's it. Just going through every single axis, comparing them with all the positions. And the kind of almost baffling thing to me is that it still relies on points so much. Or, yeah, no, everything's just points. So if I do this, and even that, okay, good. So now I just need to find a collision points method. Which I think... Yeah, how do we do that? Okay, I'm just gonna stress test this a little bit. Okay, that works good. Just want to make sure. 'Cause... There we go. So now the question is, how do I make this work with instances easily? Because again, doing this just between two boxes is, you know, probably not the best. Need to figure out how to do with all the instances. And I have the instance bounds node too. So wait, no, I can do this with instances. Because I made the instance bounds node. I just have the min and the max. I planned for this. Unintentionally. So yeah, I can get axis-aligned bounding boxes. It would take a lot more in order to make this work with instances, like all the instances, and then I would still have to go through every single instance to make sure. But... Dang, okay. So it... Yeah, no, I would need to code... Or... Yeah, no, to... I did not expect this to actually work. How about that? How about that? We're at an hour right now, so I could just end the stream. Boop. Or I can try making a version that is instance compatible. Once I have the instance bounds and all that, I can just get a collection of objects. Yeah, okay. That could probably work. Because again, it actually collides with the edges. That's insanity. That actually works. But then again, games have been doing this for probably longer than I've been alive. It actually works. How about that? But yeah, I need to find out how to get the collision points for all these. It would be isolating a pair of instances, doing this, and then outputting a thing per pair. That could work. Alright. Time to make a instance compatible version. Oh, new collection. We have one there and there. We hide you. And then we have a plane just in the scene collection so that we can pull in the instances. Separate children, set it to relative. So now we have two instances. We can get the instance bounds and then store that. Instance bounds. And this will give us the positions of all of the vertices. Though, oh wait, that's gonna be a pain to figure out, isn't it? Because I'm turning just the min and the max. And also, before I forget, maybe there's an easier way of doing that. Here, let me reference the version that works here. So again, we have that and that. If they're not colliding, that happens, and then this runs on every single point. So, for every instance, I have to do 15 axis checks. Or 15, yeah. I have to get 15 axis distances. And then, for every one of those, I need to run 12 of the axis distance checks. And then for those 12, okay, so 15 times 12, and then we got to do this twice to see whichever one is, you know, min-max comparison. It is interesting that the separating axis theorem, I should have figured this out ages ago, but it's, you flatten it into a one-dimensional bounding box check. Yeah. Though I feel like there is a better way of doing this as well. I'm not sure. That's probably fine. That is an attribute statistic, so making it even simpler than that may be a pain. And then this part, I feel like I could make this even simpler as well. Like this with the... Use the instance transform node. Let's make a... Let's see. So here, just to get the axes of the instances, I just need to... Dang, this is going to be such a pain. Just sample index. And this only works with 2 when I need to make it so many more. Kinda sucks. I can extract the instance transform to get the 3 axes, assuming that they're not scaled, but I can normalize the axes if so. Everything is easier if I just make the bounding boxes axis aligned, isn't it? Which I can't do. And even this does get the edge-to-edge collisions. So if I just had 2 objects, 2 cubes, I could, in theory, get that to work. But, again, here, if it's not colliding, we go and use... I need to figure out the collision amount. That's a greater than or less than. I would just need to use a subtract between min and the max here. It should give us the collision amount. I'll figure that out off stream. I think I've done enough for today. But just getting the base collision, that works. That's good. And even not copying it straight from code, that is, I'm happy that I was able to figure that out. Though, when you lay it out like this, it's not that bad. At least in its current iteration. Like, this is just finding the axes, and that's not too bad. Just switching between the methods, just having a axis index as the input, and then having all of this as the output. Yep, just switching the modes. And then this part, it's like, oh, it's so difficult, and then all of a sudden, like, it's that. Ugh. I think the biggest part that helps is that I thought I might have to get the median position, but I guess I kind of am, just along that and then doing that. No, that's not the worst. Not the worst. But it still needs to do some sorting with the attributes statistic node and all that. But anyway, it does indeed work. So let me just hide this again because I want to check the... Where's the one with all the duplicates? Ah, yes, it's you. Again, if it's not colliding... Just want to put in that icosphere again. With the radius, if it's not colliding, that's just a very, very smart debug tool I have. Wait, why is it not? Oh, because they are colliding at the moment, yeah. It's interesting to see it develop over time. Just seeing the separating axis theorem in motion. That is interesting. It's just doing 15 dimensions of one-dimensional collisions. And the darn cross product. And there should be... There should be an icosphere here. Unless I screwed with, parts. Or am I just not moving the... Oh wait, one of the cubes is different, aren't you? Yes. The cubes is a different size, so while that one's colliding, the other one is not because of stuff and things. Hiding you as well. So this one, if I were to join the main one into there so that I can actually see what's going on, we would see, yep, according to the debug, it's happening, then that's happening. Okay. So now I just need to figure out how to make it work well. Yep. And then for edge-to-edge collisions. And now that I have this figured out, this should work for any... If I set it up correctly, it should work for any shape. Like triangle-to-triangle collisions. Because in theory, once again, edge-to-edge, face-to-face, corner-to-edge, and all that. But no, it's more complicated with mesh because you need to deduplicate collisions with edges, because if I did it for every single triangle, it would keep redoing edges again and again and again, making it very inefficient. Back there, collision, no collision. That one's weird. Then if I rotate, we can see the other axes doing that, which is fun. So again, it's just colliding with the 3 axes here, and then the cross product of every single one. So 3, 3, and then 3 to the power of 2. Or 3, 3, then 3 times 3. So yeah, if I were to do this per face, or per triangle, each cube has 12, so it would be 24, well, 12 plus 12 plus 12 times 12, which becomes very expensive very fast. Yeah, that is fun. That is so fun. Sphere collisions are so easy. That's what I'm learning. Sphere collisions are so easy compared to boxes. Where's the one that works again? Alright, it's you. The one that switches color. It's beautiful. Because, again, I don't think... Even if I used my SDF one, I don't think it can do edge-to-edge collisions. How would I get the collision point? It would be... If everything is not colliding, it would just output the axis plus, you know, it would just be that plus the median times 2. The one that is, subtract the min from the max to get the midpoint between the two. Subtract the min from the max, add them together, and then divide by 2. Get the average. Right now I'm just getting the midpoint between the two there. Even though I could get the mean between both of those and but we're just going off the min and max parts here. Then we use that to scale the axis. Then that gives us our collision offset distance, potentially. So, if it is not colliding, now we need to make it so that if it is colliding, it'll add to the result. But no, I want the minimum one to go to the result, which means I would have to do another sort every single time. Pick the min. Actually, wait a minute. Yeah, no, I would just need to have an array of every single axis, then every single collision distance. And then that would tell me the amount compared to... No. That's enough for today. My brain is frying. But it was successful. Which is weird to say. I did not think it would be. Yep. Alright, thank you all for watching. I'll see you next time. Have a good one. This stream will probably be unlisted. Or maybe it should just be public. I don't know. I'll leave it public, okay. Because someone might find a better way of doing it. Alright. See you all. Have a good rest of your holiday weekend.